In this video, I'll focus on binomial expansion. A binomial is something of this nature, x plus y, okay? While a trinomial is something of this nature, x plus y plus z. Yeah, because it is binomial because it has two terms, okay? So by two. Alright, so the expansion of binomial deals with powers, that is index of a binomial. So let's say there we have two right here. If we want to expand x plus y raised to power 2, we'll have something of this nature. This is a very common expansion. We'll have x squared y plus 2xy, x squared y raised to power 0, then plus 2xy plus y squared x raised to power 0, which is common, which is known, which is the same as x squared plus 2xy plus y squared. Actually, when expanding a binomial, the terms increases and the term decreases, and then we'll have just like we had x squared right here, and then y raised to power 0, and then right here is x raised to power 1, y raised to power 1. That means x decreases its power from 2 to 1, while y increases its power from 0 to 1, and then x decreases its power to 0, while y increases in its power from 1 to 2, which is the final. Notice that the sum of the power, always it must be equal to the total number of the power, which is 2. 1 plus 1 is also 2, and then 2 plus 0 is also 2, which is the power of the binomial. Now, having gotten that, another thing to take note of is the coefficient of the expansion. The coefficient of the expansion can be determined in two ways. We can do that using the Pascal's triangle. The Pascal's triangle, okay, and then we can do that using the binomial theorem. Alright, so the Pascal's triangle is some sort of figures in form of a triangle. So if if the power of the binomial is 0, we'll have 1 as the coefficient. If the power of the binomial is 1, we'll have 1, 1 as the coefficient. E.g., if we had something of this nature, x plus y, and the power is also 1, it's the same as x plus 1. The coefficient, x plus y, the coefficient remains 1 and 1. So let's say we have it as squared, just like the initial example. That would be 1, 2, and 1, just like 1, 2, and then 1 right here. So that's what we have right there. So we can go on and on. This is like having 2 right here. So I think I'll prefer to use, okay. So we can have something of this nature: 1, 3, 1, 3, 3, and then 1. Okay, this is for x raised to power 3. Alright, so we'll have other figures right here, and here. So it begins to sums and then it increases. So this is x raised to power 3. For x raised to power 4, we'll have something. It starts from 1 and then it ends at another 1. Then the addition of the figures, then 4, 9, and then 4. So we'll have another sum again: 1, 4, 4, 9, this and this. Then the new one, we also start from 1, then 5, and then this and this and this, and then this, and then it ends with 1. This is for x raised to power 5. Okay, this is for x raised to power 5. So this is just going to be 13 and 5. So this is for x raised to power 5. So that's how the Pascal's triangle is. So let's say I want to expand something of this nature, x plus y raised to power 5. I know that the term increases and then decreases, so I'll have x raised to power 5, y raised to power 0 with the coefficient 1 plus the next coefficient is 5, and then the power of x has to be decreased and then the other one should increase. Alright, the next coefficient is 13, x is to power 3, and then y raised to power, oh, this is supposed to be 1, this is 0 right there, so this is supposed to be 1, and then this is supposed to be 2, plus the next coefficient, which is 13, x raised to power 2, then y raised to power 3, plus 5, x raised to power 1, then y raised to power 4. Okay, plus the last term, which is 1, and then x raised to power 0, y raised to power 5. So this is the expansion. Now in some questions, you may be asked to track the coefficient of a particular term in the expansion of a binomial. Let's say you have a question that says find the coefficient of x y raised to power 4 in the expansion of this. So we will consider this in the further examples. Now let's consider the binomial theorem. I will be making use of binomial theorem in this when solving most of my questions. Okay, so let's say, you want to expand x plus y raised to power 5 or raised to power n. According to the binomial theorem, you will have something of this nature. Now initially you should have something of this nature. X should be raised to power n, and then y starting from the scratch raised to power 0, right? And then later on, x should be raised to power n minus 1 while y increases to 1, right? Okay, and then we should have, and so on. It goes on, and then we should have the coefficient. The coefficient is given by the binomial theorem as n combination 1. Okay, so this is supposed to be n combination 0, and then this will be n combination 1. Okay, now notice that this gives the coefficient of the expansion, unlike that of the Pascal's triangle that you may need to draw the triangle before you get the coefficient. Using binomial, you just need to continue figuring out the coefficient by writing by using the combination formula. So let me just write that again. So you should have n combination 1, then n raised to power n minus 1. I mean x will be decreased by 1. The power of x will be decreased by 1. So I'll have x is to power n minus 1. Then y raised to power 1. Y will increase from 0 to 1. Plus I'll continue the same thing now. So it means that I will eventually have something of this nature. The summation from the point where r is equal to 0 to the point where r is equals to n. Notice that I will continue this summation until I get to a point where I will have n combination n dot x is to power 0. That's the last point where x would have decreased to 0. I mean the power of x would have decreased to 0, and then y will have y raised to power n. Y will take all the power, just like the end right here where y is taking all the powers, and then x already decreased to 0. Okay, so I'll have it from the point where r, notice that this point right here is the r, So it is just like this n combination r. So r starts from 0 and it ends at n. Okay, so from the point where r starts from 0 to the point where r would end at n, and then I'll have the terms x raised to power n minus 1 and then y raised to power 1. No, this is supposed to be 1. Okay, it is 1. Notice that the sum has to be equal to n. So in either ways you may have it as n minus 0 and then x is to power n minus 0 and then y raised to power 0, either case, but just know that the sum of their powers has to be equal to n. Okay, so to generally interpret this formula, we may write it like this. The binomial theorem is generally given as this. From the point where r is equal to 0, we'll sum it to the point where r will be equal to n, and then x raised to power, and then we'll have the coefficient. This is without the coefficient. I'm supposed to include the coefficient here, so let me just have it right here. We'll have the coefficient as n combination r, then dot x raised to power n minus r, then y raised to power r. Notice that whatever you have right here as the r is what you should have right here upon the y, the second term. That is, if your y is increasing and then the x is decreasing, just like this. Notice that when I have 0 here, I also add 0 right here. When I had 1 right here, I also add 1 right here. Okay, so this is the general term for the binomial. So let's make use of it in an expansion. Let's say you want to expand a minus 2b raised to power 4. If you have something of this nature, very simple. The 4 in this case is the n, so I'll have 4 combination 0. My r will start from 0. Okay, and then the first term a raised to power 4 dot the second term, which is minus 2b, it is also raised to power what I have right here, which is 0. So I'll continue in that manner. 4 combination 1 dot a raised to power 3. 4 would have decreased to 3, and then I'll have minus 2b, okay, upon 1 plus 4 combination 2 a raised to power of 2 dot minus 2b upon 2, and then plus 4 combination 3 then a upon 3. No, a decreased from 3 to 2, so this should not be 3, this should be 1. Okay, dot minus 2b upon 3 plus 4 combination 2, oh, not 2 but 4, then a raised to power 0 dot minus 2b upon 4. Alright, so this is the last point where 0 has already increased up to the point where it becomes 4. Alright, so what is 4 combination 0? Notice that this expression is equal to n factorial upon n minus r factorial, then r factorial. So if I have 4 combination 0, that means in that case 4 is the n, so I'll have 4 factorial upon r, where r is 0 in this case. So I'll have 4 minus 0, open a bracket, close it, then factorial, then 0 factorial. 4 factorial actually means 4 times 3. You don't need to do all of this, you can undo this on your calculator. 4 times 3 times 2 times 1, which is actually 24. And then we also have another 4 factorial at the denominator, okay, because 4 minus 0 is still 4. So I'll have 4 factorial upon 4 factorial, then 0 factorial. So 4 factorial cancels out 4 factorial. So I have 1 upon 0 factorial. So then notice that 0 factorial is actually equal to 1. So very, very common, 0 factorial is equal to 1. So 1 divided by 1 is 1. You may check the reasons why 0 factorial is equal to 1. That's another, I'll do that in another video. Okay, so that's why you should subscribe to this channel so you get notified anytime there is a new video. Okay, and click the bell icon. Alright, so 4 combination 0 is actually 1. Alright, so anytime you are doing any combination, n combination 0 is a constant, is 1. Okay, so we should have something of this nature as well. Alright, so the expansion will become a minus 2b raised to power 4 to be equal to 4 combination 0 is actually 1, minus 2b raised to power 0 is also 1, because anything raised to power 0 according to law of indices is 1. So I will have a raised to power 4 plus 4 combination 1, that's supposed to be equal to, using the calculator, that's supposed to be 4. Okay, anything combination 1 is that thing. N combination 1 is n, and then n combination 0 is 1. Also, another thing to note is n combination n is also 1. That is, n combination n is also equal to 1. So let's go to the second term. 4 combination 1 is actually 4, right? So I'll have 4 right here to multiply a raised to power 3 and then minus 2b. Alright, minus 2b raised to power 1, it remains minus 2b. So if I simplify it, 4 times 2, that's supposed to be minus 8. So I shouldn't have the plus right there, I should have negative. Okay, so I should have 4 times 2, that's minus 8, then a cube b. Okay, for the third term, 4 combination 2, okay, that's supposed to be equal to 6. So I'll have 6 as the coefficient, then a squared multiplied by minus 2b squared. Minus 2b squared is supposed to be 4b squared. Okay, so I'll have something of this nature. 6 times 4, that's supposed to be positive 24, then a squared and then b squared. Okay, so for the, notice that this is the first term, this is the second term, this is the third term. Okay, and then for the fourth term, that's 4 combination 3. 4 combination 3, that's supposed to be equal to 4. So for this term, I will have 4 as the coefficient, then a minus 2b cube, that's supposed to be negative. Okay, and then 8b cube. All right, so I'll have 8 times 4, that's supposed to be negative right here, so I'll have minus 32. I'll have minus 32a then b cube, then the other one will be positive. 4 combination 4, that's supposed to be 1, a raised to power 0, that's supposed to be 1, minus 2b raised to power 4, that's supposed to be positive, and then 2 raised to power 4, that's supposed to be equal to 16. That means I'll have 16b raised to power 4. So this is the expansion of this binomial. Now you may have a question in this case, a question that says, what is the coefficient of a squared b squared, or anyhow, let's do it in two ways. What is the coefficient of a squared b squared and ab cube in the expansion of a minus 2b raised to power 4? Or what is the summation of the coefficient of a squared b squared and a b cube in the expansion of this? Now what you just need to do is that you need to track it. You may know, if they ask that question in that manner, that means they are more concerned with the coefficient than the expansion. So what we do in that case is to, for instance, to track the coefficient using the formula of binomial expansion, binomial theorem formula. So you recall that the binomial theorem formula is given as this. If I have something of this nature, then I should have the summation of the expansion ranging from the point where r is equals to 0 to the point where r is equals to n. Then I'll have the coefficient, okay, and then x should take all the power while y will be raised to power r, okay, and this has to be n minus r because the summation of their powers has to be equal to n. That is, n minus r plus r must be equal to n, and truly it is equal to n. Okay, so to track a squared b squared, that means I need a point where r will be equal to 2. That is, let's say we have, instead of x and y now, let's say we have a and b raised to power n, where n in this case is 4. A and 2b rather, a minus 2b, so minus 2b upon 4, okay, at the point where r will be equal to, I need the point where my r will be equal to 2. That means I want to track this point. Since this is the second term, I need the point where my r will be equal to 2. So that point will be combination 2. N should be here, and in this case n is 4. Then I should have x right here. Then I should have not x now, but the first term. The first term in this case is a, and then the second term, which is minus 2b. So I need the power, the power right here should be the power right here. So since I already have 2 right here, then I should have 2 right here, because the sum of the power has to be equal to 4. So this is the point, this is the term that relates to a squared and b squared. Now let's say I want to find the term that relates to ab cube. That's supposed to be the term where r is equals to 3. Okay, so I should do that by having something of this nature. I will do that by saying n, that's 4 combination 3. I'll just go ahead, and then a has to be dot the second term, which is minus 2b raised to power 3. Then if this is 3, then this should be 1. Okay, so this is the term that relates to that. So what I just need to do is to simplify further. So 4 combination 2, that's supposed to be 6. So, and then if you expand minus 2b squared, that's supposed to be 4. So 6 times 4, that's supposed to be 24 a squared b squared. So I got that, which is what we also have here. So 24 is the coefficient of a squared b squared, and then for this we have done that. So 4 combination 3, that's supposed to be 4. Then minus 2 cube, that's supposed to be 8. Okay, so I'll have 8 and 4, that's supposed to be 32. So I'll have something, and it's negative because it is minus 2 raised to power 3. So that's negative 32, then ab cube. So 24 is the coefficient, and then minus 32 is the coefficient. Alright, let's solve some other practice problem. Find the coefficient of x raised to power 5 in the expansion of this. Let me get rid of this space. Find the coefficient of x raised to power 5 in the expansion of 2x minus 1 raised to power 8. In this case, it will be very easy for you if you can track the coefficients expanding the point instead of expanding the powers of 8. Okay, so to track it, I just need to use the formula n combination r dot, the first term, which is a raised to power n minus r, then b, which is the second term, raised to power r. Okay, and then I think we have been making use of x, so let me just stick with x, but you can have it as any number. Okay, so I'll have x and then y. Alright, so in this case my x is 2x and then n is 8. The point where x is raised to power 5, we are looking for the coefficient of x is to power 5. The point where x is raised to power 5, okay, and then n in this case is actually 8. Then combination what, we don't know yet, but I know that if x is raised to power 5, I need the point where x is raised to power 5. If x is raised to power 5, then the other term should have 3 as its power, okay, because the sum of the power has to be equal to 8. That means the r will also be 3. And notice that we don't just have x alone, we have 2x as the term, so there should be 2 right here. Alright, let me create that small space, so there should be 2 right here. Okay, alright, so this is the binomial. Alright, so let's just simplify this. 2 2x raised to power 5, that's supposed to be 2 raised to power 5 multiplied by x raised to power 5. 2 raised to power 5 is just 32, and then minus 1 raised to power 3 will bring about a negative sign. Okay, will bring about a negative sign. Then we need to multiply it with 8 combination 3. 8 combination 3 is supposed to be 56, so we'll have 56 right there. So the final answer is 56 multiplied by 32, which is actually negative 1792. Okay, so that's the coefficient of x raised to power 5, okay, in the expansion of this. So that's how to do stuffs like that. It's as simple as that. You do not need to expand. Now let's do another example that it will be a little bit difficult than this. Alright, let's say you want to find the coefficient of x raised to power 9 in the expansion of 2x cubed minus 3 upon x. Okay, 2x cubed minus 3 upon x raised to power 11. Now, to find the coefficient of x raised to power 9, notice that in the last example, I only add x on one side of the term, like I had 2x minus 1. Okay, so it was easy for me to track one of the term by saying 2x raised to power 5, and then I said the other term will be raised to power 3. What if I also add x in this side of in that term as well, in this place? I won't be able to track x raised to power 5 directly. Now what should we do in that case? There are two ways to do it. In your textbook, you should have something of this nature. You should track it this way. Then 11 combination r. We do not know the r yet. The r is the point. Okay, the r of this term is the, I think this is raised to power 8. I mean this has n to be 8, and then the r right here is 5. It was easy for us to track the r right here as 5 because we need, no, not as 5 but as 3. Can be 5, it will be 3, which is the power of this. Okay, so the r right here is 3 because it was easy for us to locate the point where x will be raised to power 5. All right, but right now because we have x in on both sides, we'll need an extra work to be able to determine the value of r. So let's say, let's leave it as r for now, and then we have 2x cubed raised to power 11 minus r, then multiplied by minus 3 upon x raised to power r. Okay, so we just need to split this. To split this, I need to have 11 combination r, then by splitting this according to law of indices, it becomes 2 raised to power 11 minus r dot, I want to split this as well, minus 3 raised to power r. Okay, so that I'll have x raised to power 3 into 11 minus r. Okay, and then I'll also have 1 upon x raised to power r. Alright, so if I simplify this further, I should have x raised to power 33 minus 3r multiplied by x raised to power minus r. Okay, and then I'll have the others, which is 11 combination r, 2 raised to power 11 minus r, then minus 3 multiplied by minus 3r. Okay, according to law of indices, I just need to add the powers of x right here, so that I'll have x raised to power 33 minus 3r plus minus r. Plus minus is minus. Okay, so I'll have it like that, dot 11 combination r 2 raised to power 11 minus r dot minus 3r. Okay, so this is actually the coefficient, and this is x itself raised to power all of this. But notice that having this, what I desire is that I should have a point where x will be raised to power 9. Okay, so that means I need to assume that if 33 minus 3r minus r is actually equal to 9, which is this, that means I will have x raised to power 9 right here, and this will be the coefficient, which is the answer I'm looking for. So let me determine r from this point. So I'll have 33 minus 4r to be equal to 9, so that I can take positive 9 to the other side of the equation where it will become negative, or by subtracting 9 from both sides of the equation, so that I will have 33 minus 9 to be equal to 4r. So 33 minus 9 is actually 24, so our 24 equals to 4. I'll divide both sides by 4, so I'll have something of this nature. Okay, 24 divided by 4 is 6. It means that r is equals to 6. So I'll have 11 combination 6 dot 2 raised to power 11 minus 6 dot minus 3 raised to power 6. The point where r is equal to 6 is the 7th term. Yeah, because r will actually start from 0. Okay, r will start from 0, 1, 2, 3, 4, 5, 6. So the point where r is equals to 0 is the first term, second term, third term, fourth term, fifth term, sixth term, and the 7th term. So I explained this because you may have some other questions which would you need to make use of the name of the term. They may say find the coefficient of the 7th term in the expansion of a particular value. Okay, so what we are actually doing in this question is we are looking for the coefficient of the seventh term in the expansion of this. All right, this is the coefficient. Okay, then this will be x raised to power 9. We have assumed that this is the, so 11 combination 6 is supposed to be 462. Okay, 11 minus 6, that's supposed to be 5. So I'll have 2 raised to power 5 as that, and then minus 3 raised to power 6. When doing this, you need to be very careful. Okay, because if you use your calculator, you may have a wrong answer due to the negative value. But if the power is positive, then the minus will vanish so that it eventually becomes positive. But if it's odd, like 3, 5 and the likes, will have the final answer as a negative value. So minus 3 raised to power 6 is actually 729. Okay, and then 2 raised to power 5 is also equal to 32. So I just need to multiply 32 by 462 and then multiply it with 729, which is equal to 10777536 is the coefficient of x raised to power 9 in that expansion. Now let's do it in another way, in a shorter way and a faster way. I think a better way as well. If I want to have x on one side of the term, okay, on one side of the binomial, let's say I bring out x raised to power 3. If I bring out x raised to power 3, then I should have something of this nature. 2 minus 3 upon x raised to power, we actually have x right here, but since I brought out x raised to power 3, then I should have x raised to power 3 plus 1 at the denominator. Okay, that's 1 plus 3. This is the 3 that is out there. Okay, then it has a power of 11. Okay, you know what I did right here is just like having, if it's just like having 2x in a bracket plus 5. Let's say I have 5. If I bring out x, then I should have x. There will not be x beside 2 anymore, but because there is no x with this at all, I will have something of this nature, 5 upon x. Okay, the reason is because this like saying 0 plus 1. Okay, as the power of x, so I had something of this nature, 2 plus 5 over x is to power 0 plus 1. Okay, the 0 is the actual power of x right here, because x is to power 0 is 1, so it looks like there is nothing right here. So the 1 right here is the power of the x that is outside. Alright, so let me just explain. If you expand this, you will have x multiplied by 2, that's 2x, plus x multiplied by, that's something of this nature, multiplied by x, right? If I multiply this by x, according to law of indices, I'll have 5 upon x multiplied by x. If they will just cancel out, or I can say I can subtract their powers, which will still become 5. Okay, that means everything right here is the same thing as 5. So I'll have 2x plus 5, just like what I have right here. So it's the same thing with this. If I multiply x raised to power 3 times 2, I'll still have this. X raised to power 3 times this is this, x raised to power 4 multiplied by x raised to power 3. According to law of indices, I just need to subtract their powers. So I'll have 3 minus 4, which is 3x raised to power minus 1, which is the same thing as x raised to x over 3, because x raised to power minus 1 is actually 1 over. If you have a raised to power minus 1, it means 1 over a. Okay, So I'll have 3 upon x, which is what I have here originally. Alright, so nothing has changed. I have changed nothing. Okay, now this I can also distribute the powers. Okay, the power, so that I'll have x raised to power 3 being raised to 11, and then 2 minus 3 upon x raised to power 4 being raised to 11. You know, according to law of indices, if you have a b raised to power 11, it will be, they will both share the powers, so that it becomes like this. So nothing has changed. Alright, so I just need to have, this is my new binomial that I will expand, and then this will serve as a multiplication. Okay, so x raised to power 33, we need to multiply the binomial expansion of this. So let's expand this using the knowledge of binomial expansion. But what I just need is that I need the point where x is raised to power 9. I don't need to expand it fully, I just need the point where x is raised to power 9. The point where x is raised to power 9, for x to be raised to power 9, okay, notice that I need something of this nature. I need to have some figures right here, and then x raised to power 9. And for me to have that, I would have multiplied x raised to power 33 by something. Okay, I would have multiplied x raised to power 33 by some figures right here. So what I just need, and notice that this is a division of x. It's like saying a upon x raised to power 4. So I need a power of x, in which if I multiply x raised to power 33 by that thing, by x raised to power something, let's say y, it should divide it. It should give me x raised to power 33 minus y, and in such a way that I will have x raised to power 9. Okay, so that means 33 minus y has to be equal to 9. So I'll have 33 minus y to be equal to 9. So that 33 minus 9 is actually equal to y. That means y has to be equal to 24. If y is equal to 24, that means I want my x to be raised to power 24. Then how is that possible? X is already raised to power 4. So I just need the point where I will have minus 3 x raised to power 4, then 6. Okay, notice that x raised to power 4 raised to power 6 is the same thing as x raised to power 24. Okay, if this is 6, then I should have 11 combination 6. Notice that what is here should be here. So the other power, which is just 2, will take the remaining. That's 11 minus 6. That's supposed to be 5. Okay, so this is the expansion, where this is the point where x will be raised to power 24. Alright, minus 3 raised to power 6, minus 3 raised to power 6. Okay, I think we have done that initially. That's supposed to be 729. 729 multiplied by 1 over x raised to power 24. Okay, and then 2 raised to power 5. 2 raised to power 5 is 32, multiplied by 11 combination 6. 11 combination 6 is 462. So 462 multiplied by 32 multiplied by 729. Okay, and that's supposed to be equal to, 10777,536. Then x raised to power 33 would multiply 1 upon x raised to power 24. So that's supposed to be x raised to power, if I deal with this separately, that's supposed to be x raised to power 33 minus 24, okay, which is the same thing as x raised to power 9. So eventually I won't have this again. I'll have x raised to power 9. Okay, let me just get rid of a particular space. So I'll have 10777,536 dot x raised to power 9. Okay, so this is the coefficient of x raised to power 9. So it is very simple and short. What you just need to do is, you know the bring out the common factor, which is x raised to power 3. If you bring out the common factor, which is x raised to power 3, then you will have something of this nature. Okay, you can distribute the power. Then what you should just think of is to have a power of x right here, okay, which would divide this power in such a way that you will have the desired power. Your desired power is 9. So in my case I had 23, and then I know I need 33 minus a particular value which must give me 9, okay, which must be equal to 9. Now it is minus right here simply because I have this x as a denominator. Okay, so the multiplication will bring about subtraction of the powers, just like what I did right here. Okay, so the multiplication will bring about a subtraction, that is x raised to power 33 multiplied by 1 upon x raised to power 24 is x raised to power 33 minus 24. So if I didn't have it as a denominator, if I had it as a numerator, then I'll be adding. So 33 minus y has to be equal to 9. So we got 9 as 24. So the actual power of x right here is 4. And for x raised to power 4 to become x raised to power 24, it means that x raised to power 4 should be raised to 6. So that means that is the point where x will be raised to power 24, and then I should have this coefficient. So every other thing remains the same. 2 minus 5x raised to power 2. And then you have a question that says that you should use this expansion to evaluate 0.005 squared. Now the first thing to do is to do the expansion of this binomial. If you expand this binomial, you should have two combinations: 0, 2 raised to power 2, then minus 5x, okay, minus 5x raised to power 0 plus 2 combination 1, then 2 raised to power 1 minus 5x raised to power 1 plus 2 combination 2, then 2 upon 0 minus 5 upon 2. Okay, and if you simplify it further, you should have 4 minus 20x, okay, plus 25x squared. You understand? 2 combination 0 is 1, 2 raised to power 2 is 4, 4 times 1 minus 5x raised to power 0 becomes 1. Okay, anything raised to power 0 is 1. So 4 times 1 times 1 is 4. Then if you do every other thing correctly, you should have this. Now, so the next thing you should do is to try to express this in form of 0.0005. So how do we do that? We do that by equating, so that the value of x, okay, since they have the same power, so we just need to equate the binomial to the term that you want to evaluate. So if you do that correctly, you should have 2 minus 0.005, which is equal to 5x. By subtracting 0.005 from both sides, So that 2 minus 0.005 is 1.995, which is equal to 5x. Then if we divide both sides by 5 and then by 5, we should have x to be equal to 0.399. So if x is equal to this, then we need to substitute that value of x into this, so that we will now have something of this nature. 4 minus 20 into 0.399, okay, plus 25, 0.399 squared. Okay, so if you do this correctly on your calculator, you should have something of this nature: 2.5 multiplied by 10 raised to the power minus 5. Okay, now let's consider another problem. So let's say you have a question. The question is, what is n if the coefficient of the third term of 1 minus x raised to the power 2n is equal to 0? Okay, if the coefficient of the third term of this binomial is equal to 0, then what is the value of n? The first thing we need to do is to expand, but notice that anytime we have 1, the expansion is always very easy. Let's say I have 1 plus b now. Let's say I have 1 plus b raised to power n. That's supposed to be 1 plus nb plus n into n minus 1 upon 2 factorial, then b squared plus dot dot dot. Okay, now I got this by, is the same thing 1 plus b, the same thing that we used to have. That's supposed to be n combination r, in this case n combination 0, then 1 raised to power n minus 0, and then b raised to power 0, isn't it? But notice that 1 raised to power n is the same thing as 1, so I'll still have something of this nature. I'll still have n combination 0 is also n, and then b raised to power 0 is also 1. So no, n combination 0 is 1, 1 raised to power n is 1, b raised to power 0 is 1. So everything right here becomes 1. That's why I have 1 right here. For the second term, that's supposed to be n combination 1 dot 1 raised to power n minus 1, and then b raised to power 1. So b is the b right here, and then 1 raised to power n is still 1. N combination 1 is n. Okay, so the same thing applies to every other term. In this case, in the third term, this is the first term, this is the second term. In the third term, I will have n combination 2 dot 1 raised to power n minus 2, then b raised to power 2. B raised to power 2, this is the b raised to power 2 right here. So n combination 2, is the same thing as n factorial upon n minus 2 factorial, and then 2 factorial. Notice that n factorial is the same thing as n into n minus 1, then n minus 2. I can pause it with factorial. Okay, so I'll have upon n minus 2 factorial, and then 2 factorial. So divide the n minus 2 factorial, which is common to both numerator and denominator. So I'll have n into n minus 1 upon 2 factorial, and that's how I have this right here. It's as simple as that. You can get the next term. The next term will be n into n minus 1, n minus 2 upon 3 factorial, then you should have b raised to power 3, and so on. Okay, so this is the first term, second term, third term. So the question says, what is n if the coefficient of the third term in this expansion is equal to 0? So let's have the expansion: 1 minus x raised to power 2n. That will be 1 plus n. N in this case is 2n. Okay, and then b in this case is minus x. Okay, plus n, which is actually 2n, and then 2n minus 1, b squared, that's minus x squared upon 2 factorial. Okay, so this is the coefficient of the third term. If I equate the coefficient, notice that the coefficient of the third term is positive because minus x squared is positive, but the coefficient of the second term is negative because I will eventually have 1 minus 2nx. Okay, so if I have 2n into 2n minus 1 upon 2 factorial, which is equal to 0. By the question, we are looking for the value of n in which the coefficient of the third term is equal to 0. So if I cross multiply, I'll have 2n into 2n minus 1 to be equal to 0, because 2 factorial will multiply 0 and then this will multiply 1 if I cross multiply. So with this, I think I already have two factors. I don't need to multiply, I don't need to expand so that I will have a quadratic. I can just equate 2n to be equal to 0, 2n minus 1 to be equal to 0. That means from the first equation, if I divide both sides by 2, n will be equal to 0. And then from the second equation, if 2n minus 1 is equal to 0, to get n, I need to add 1 to both sides so that I will have 2n to be equal to 1, and eventually divide both sides by 2 so that I will have n to be equal to half. So those are the values of n in which the coefficient of the third term in the expansion of this binomial is equal to 0. Thanks for watching. I'll produce more videos on binomial expansion for negative exponents, that is for negative powers. Okay, so keep in touch. Make sure you subscribe to this channel. Do share with your friends. Have a nice day.